G here. Today we're going to be starting our finance review. So before spring break, if you didn't remember, I know it's been a while, we were doing some finance stuff. We were doing calculations for interest, and that was kind of our focus. For this first video, we're just going to focus on finance review related to simple and compound interest. I put some links in the description here on the video as well as on the post on Teams to look at my old website for the old material, and I would encourage you to use that as review as well. Some terminology before we get started. So interest, this is the extra money that you earn, and the key here is extra. So when we're doing these calculations, this is all the extra money that you didn't start off with. The present value, that's how much money you have right now or how much money you start with. And future value, that's how much money you have at the end. To calculate the future value, you would take your present value and add your interest. So the extra along with what you started, that gets you how much you have at the end. Two other things to remember. R is what we use for our annual interest rate, what percentage we earn every year, and N is going to be our number of years. Using all that, we can go first to simple interest. Simple interest is calculated like this. Our interest is the principal times the rate times the number of years. If we wanted to get the future value, which is the total, we would just have to add in our principal again. If you remember, our equation was that future value is equal to principal value plus interest. So that's where this second equation is coming from. So let's do a calculation. Principal value equal to $100 and our rate equal to 2% annually. So let's do our calculation for 1, 2, 3, and 4 years using our equation. Principal value 100, rate of 2%. Our future value would be calculated using principal value plus principal value times our interest rate, which we need as a decimal. Put this as a decimal, it would be 0.02 times the number of years, which in this case is 1. That gives us $102. We can do something similar for the other one. This time with 2 years, we'll get $104, and I think you can start to see the pattern. So we're going up by $2 each time, so every year we gain $2 on our investment. It's always going to go up by the same amount every year. Now I want to make a note about simple interest. This is not really used in real life. Most of what is used in the real world is compound interest. For compound interest, the first example we're going to do is compounded annually, so that means we're recalculating our interest every year. And this is our equation, future value equals present value times 1 plus our interest rate to the power of the number of years. We'll use the same numbers as last time. To calculate our future value, we use the equation, and you'll notice we get the same answer as we did for simple interest after our first year. That's not a coincidence. That's always going to be the case when we're compounding annually after 1 year. But then we start seeing differences once we go past 1 year. So we can use the equation that we did above, but I want to also point out this is the same thing as this right here. So if we take our previous answer and multiply by our 1 plus 0.02, 1 plus 2%, so everything we have plus an extra 2%, it's going to be the same as just using our formula. So what this tells us is for compound interest, we're actually charging our interest, our 2%, on our previous amount. That means compounding. We're charging interest on the money that we have, not the money that we started with. With simple interest, we were always charging interest on the money that we started with. And we get this answer, which if you'll notice is just a little bit bigger than for our simple interest answer. And we can do the same thing for 3 years, and we'll get this. Again, a little bit bigger than our simple interest. So if we look and compare 102, 104, 106, 102, 104.04, 106.12. So our compound interest is getting bigger and the difference is also getting bigger. This was 4 cents bigger, this is 12 cents bigger, and that's what we will always see for compound interest. Our last example is going to be compound interest compounded quarterly. What that means is instead of recalculating our interest every year, we're going to calculate it every quarter, which means 4 times per year. Our formula is almost the exact same as regular compound interest, but we have our R and our N with little stars here. This R star means the effective interest rate and N star means the number of periods. Now, how do we calculate that? We have to look at how many times per year we're compounding, this time 4 times per year. So if our interest rate, just like before, is 2%, our effective interest rate is that 2% divided by 4. Basically, we're splitting up our interest into 4 chunks because we're doing it 4 times every year. So our effective interest rate is 0.5%. 4 times a year, we are getting 0.5% of our money in interest. For the number of periods, it's the opposite. So instead of dividing by 4, we multiply by 4. If we started with 5 years and we're doing it 4 times every year, that means it's a total of 5 times 4, which is 20 periods. So 20 times that we're actually recalculating and compounding. Now let's do a table and show you the calculation for this. So present value of $100, our rate is 2%, which means our effective rate is 0.5%. So after 1 year, we've actually done 4 times as many compounds. So our number of periods after 1 year is actually 4. When we calculate our future value in our equation, we would use 100 times 1 plus 0.005 to the power of 4. This is 0.5% converted into a decimal, and this is our n star. And we get an answer of $102.02. So this is even a little bit bigger than our previous compounding interest answer, which was just $102. For the next one, now we've done 8 compound periods after 2 years, we get $104.07, bigger than both our simple interest and our compounding annually answer. If we do this for 3 years, we get an even larger answer, $106.17. This is bigger than both the simple and the annually compounded interest. So in summary, if we have the same present value, interest rate, and number of years, simple interest will always be less than compound interest. And when it comes to compound interest, compounded fewer times per year will be less than compounded more times per year. So the more often you recalculate, the more often you update your answer, the more money you have. To summarize this in a graph, this is what it would look like if we were to graph our 3 calculations over time. So if this was our future value and our number of years, our simple interest would be a straight line here. Our compound interest annually would be a curve that gets slowly bigger and bigger away from our simple interest, and our quarterly would also be a curve that again gets bigger and bigger away from our compound interest. That's the end of the first video here. Make sure you tune in for the next 2 where I go through time value of money calculations. If you want to get started on some homework, I'll put the suggestions in the descriptions, or you can just watch the next video and do all of the assigned work at the end.